In this tutorial, I will show you how to download and process the Southern Ring Nebula using data from the James Webb Space Telescope. This data can be found in the MAST portal under Select a Collection, MAST Observations by Object Name or Right Ascension Declination is automatically chosen. Simply enter the target name. All of the data for every mission that has this target is available. I find it easiest to search by mission, or if you're looking for a specific instrument, to search by that. In this case, I want the James Webb Space Telescope data, so I will click Show More and select JWST. This will show me all of the images for this particular target from the Webb Space Telescope. There are two instruments located under the Instrument tab, NIRCam, the Near Infrared Camera, and MIRI, the Mid-Infrared Instrument. I only want to process the NIRCam image, however you can process both. They are equally beautiful and fun to process. Select the data that you wish to download. If you already know what you want to download, you don't need to look at previews. If you want to see a preview of the images, you can select Album View next to List View. This will show you what each of the images looks like so you can choose which images you want to process. Usually when processing these type of images, all the filters will be combined into one image. Here under Filters, you might notice that it says F444W twice. While these appear to be the same filter, on the actual file name, I have noticed that one of them says F470W, so they are indeed two different filters. I've selected the ones I want, and using the basket with the green arrows on top, I am going to add them to my download basket. The only files that I am interested are the FITS files. There are other extensions as well for other scientific purposes, but if you're just making an image for fun, the FITS files will do perfectly. By selecting just the FITS file under the Extension tab, I can select only the images that I want. I open up each filter to see what my options are for downloading. You'll notice for Webb Space Telescope images that there is a separate segmentation map image. If you need this, you can download it, but I just prefer to download the FITS file by itself. The segmentation map is not needed to create a beautiful image. This also prevents me from downloading extra data that I do not need to download. Once I have chosen the images that I'm going to download, I then click the download button. The default is a zipped file. There are also other options to download. The download can take quite a while depending on how large your file sizes are. So do not worry if it can take quite a few minutes for your file to download. Once the files have been downloaded, they need to be converted from a FITS file to a TIFF file to make them easy to work with. I open up the files that I wish to convert from a FITS file into a TIFF file. The scaling is automatically at a linear scaling when you first open this image. I prefer to scale it using an A sign of H scaling. Once that is selected, I adjust the black levels and the white levels so that there is no black and white clipping. You can adjust these levels before you bring them into Photoshop or PixInsight. However, I prefer to just keep all of the data and adjust it later in Photoshop. I then save the image. It will automatically save as a 16-bit TIFF file selected under bit depth. If you wish to use a 32-bit TIFF file, you can. However, Photoshop does not work well with 32-bit TIFF files for now. Once I am done with each image, I will then open them up in Photoshop. When opening these images, it is best to load them into a stack. So go to File, Scripts, Load Files into Stack. Load all 6 of the files that you wish to work with. You might notice that when you load all 6 of these files that they are actually different sizes. The first 3 that have loaded here fill up the entire image. However, the last 3 only fill up the top left corner. So the images are not aligned and need to be aligned in order to create the full image. This can be done manually in Photoshop. I find it very hard, and I did end up purchasing PixInsight for this purpose, along with more advanced image processing software capabilities. If you have access to PixInsight, an easy way to align these images is to use the star alignment option. In PixInsight, I open up all of the files that I wish to align. When I first used PixInsight to align these images, I had tried aligning them to the first filter in my list, 090. One of the images did not want to align no matter what I did, and this was filter 470. So I decided to align everything to that filter in order to get everything to line up properly for stacking them later. To align them, you can go to Process, All Processes, and Star Alignment. The reference image will be the image that I want to align to. I have selected View, as this is what I've opened up here in PixInsight. Selecting the down arrow next to View allows me to use the image that I want to align to, in this case the tricky one, 470. Under Target Images, select Add Views in order to add every filter that is not the reference image. For ease in selecting the filters, I simply hit Select All and then unselect the original target reference image. Once you are ready, select the circle to start aligning the images. Only one succeeded and 4 of them failed. However, this is a good thing. The one that succeeded was 405444, and this will now allow me to register the rest of the images to this now aligned image. I now change my reference image to this new registered image, which says registered after the file name. I clear my target images and add the ones that did not work. I do not include the 470 because that was my original reference image, and I deselect my original 405444 image. That leaves me with the other 4 filters that were not aligned properly. I select the circle again to begin alignment. Now all of my filters are aligned as indicated by the registered word after the file name. Save every registered image that you have as a TIFF file in order to work with it in Photoshop. There will be a warning that TIFF format does not support some existing data in the FITS file format. I do not need this other data as I'm only doing an image for fun, not for anything scientific, so I select OK. The 16-bit unsigned integer is automatically chosen for TIFF. This is what it should be saved in for use in Photoshop. Once all of my registered images have been saved, I can close out of PixInsight and go back into Photoshop. I do not want my unaligned images, so I'm going to close this and once again go to File, Scripts, Load Files into Stack, and load the images that I now wish to use. Now you can see down here in the stack that every image is exactly the same size and has been aligned with each other. I always rename my files to make it easy for me to work with them. I usually name them the filter name, as that is how I colorize my images based on the filter. The filters will be in the file name itself. I then like to reorganize my filters to put the highest filter at the very top and cascading down for the lowest filter to be on the bottom. This is because the filter wavelengths correspond to the colors I will use. The larger the number, the more red the color will be. The lower the number will be more blue. One thing that NASA does when they produce these images is often provide a guide for the colors that were used to create these images. These will be in the webtelescope.org image gallery. By looking up the image that you are looking for on this specific website, the Southern Ring Nebula, I know that by scrolling towards the bottom, in the Fast Facts box, under the tab about the image, it tells the different filters used and what colors. In this last sentence here, it says in this case the assigned colors are red 470, red 405, yellow 356, green 212, cyan 187, and blue 090. This is how they created this image here. The filters are also colored on the bottom of this image as well. Now that I know what colors my filters should be, I know what to color them for each wavelength. But before I color them, I always stretch the levels in order to bring out the details before I colorize and combine the images. Starting with my lowest level, 090, I go to Image, Adjustments, Levels. You can see that most of the data has been stacked to the very left, with this really long skinny line. That is essentially data that does not necessarily have to be included in the image. In order to get really detailed and bring out the details in this image, I always move only the middle slider right up to the edge of this data on the left. I do not adjust the right slider. That is for your white level. That can tend to blow out things that are very bright, like the stars in the middle. I do not want to adjust my black slider on the left because then I will cut off this data. This image still has a very gray background and I want it to be black. I go back to Image, Adjustments, and Levels. Now my black slider is over here on the left and there is a big gap between the left side and where the data actually starts. I then bring this black slider to the very edge where the data starts. My background has become much more black and I'm happy with how this data has been stretched. I do this for each image filter. I do not stretch the data too much when I'm doing this because there are other ways to enhance the image later on. If I stretch it too much now in this stage, it can make those effects much more harsh than they need to be. Once I am happy with my levels adjustments, I will then colorize the images. Because these images are in grayscale, they need to be changed to red, green, and blue mode. Go to Image, Mode, and select RGB Color. It will ask you if you want to merge the layers. Select Don't Merge. I usually start with the bottom image, coloring it blue. Go to Layer, New Adjustment Layer, Hue and Saturation, select Use Previous Layer to create clipping mask, select Colorize. For blue levels, I like to use 200, change your saturation to 100, and your lightness to -50. I will also colorize 187, a blue color as well. Using the same exact value, I can adjust these later as needed. 212 will be my green. I usually use 120 for the green value. For my own image, I like to use yellow for 356 with a value of 40. For 444, I used a value of orange, which is 30. And for 470, I used a value of red, which is 0. Once all the colors have been assigned, select the filter itself and change your blending mode, listed here as normal, to lighten. Do this for each filter. You can see here my image looks very yellow with a purple-red hue in the center. So now that I've given my general colors assigned, I'm going to change around the color levels and their intensities to get the desired color I wanted. For 090, I'm going to give it a more cyan color. Cyan is usually around 180, and by messing with the lightness, I can change how much of this filter will be visible in the final image. This is all done to taste and however you would like your image to be presented in the end. I check each level just to see how it looks in the image, usually by adjusting the lightness value. If I wanted to, I could take the hue and change it to a different color. Simply by changing it, creates different colors for the final image. However, I do like the blue look of the center of the nebula, and we'll keep this one at blue. Once I am happy with how this image looks, I then select the very top layer, Hue Saturation, all the way to the bottom of my image, 090. Right-click and select Flatten Image. I do not want to work directly on the background layer. I will then create this new duplicate layer by holding down the keyboard shortcuts Ctrl-Alt-Shift-N-E if you are using a Windows computer. From here, I'm going to color sample my image using the color sampler tool to get my red, green, and blue values. Select an area of the image that looks dark. The info window will pop up, and under the RGB column, it will give you the RGB values for that particular location in the image. I am checking the darkest values, the black values in the background of this image. I then go to Image, Adjustments, Levels to bring them all equal before I begin processing. Under Channel, I select Red. Because my black point is all the way to the left and there's not a lot of data there and I want to adjust it up to make them equal, I will adjust it up 1 point to 10 using my midpoint range. From here it went from 9 to 10. I select green next. There is a gap in the data, so I will drag the leftmost slider down to 10, making sure it matches up here. The same for the blue channel, there is a large gap, and I will slide it to match this. Here is what my previous image looked like, and now my current image has a much darker background. I then create another duplicate layer from the previous layer. From here, I will adjust the curves under Image, Adjustments, and Curves. I usually grab right in the center to start and pull it up as far as it will go to where the bar is almost hitting the top. I then grab a point inside the data itself and drag it down a little to get the background dark. And then adjust each of these points up or down to what I think looks best. Once I am happy with the result, I select OK and create another new duplicate layer. Then I go to Layer, New Adjustment Layer, and Selective Color. This will allow me to change the colors in the image to something that I find pleasing. It always begins with red, and I just go through each color to find what I like best. I just experiment by using -100 and 100, which are the minimum and maximum levels. I then go to yellows next. Sometimes a color is not very prominent in an image and will be harder to bring out. I know there is not a lot of green in this image, so I do not bother with that color. I check to see if there's any cyan. I do not see any. And next I will adjust the blue. I will check my magenta last. Once I am happy with the colors, I always go down to black and give it at least a value of 3. This darkens up the background and any black parts of the image to give it a nice even background. When I am done, I will create another new duplicate layer and then go to Filter, Camera Raw Filter to enhance my image. The settings that I usually adjust are under the Basic tab, which should automatically open. I always like to adjust the temperature, the exposure, add some contrast, and just play around with the settings until I find something that I like. Here's my current image, and here's the previous image. I was able to lighten the background dust so that it stands out more. I'm quite happy with the way this image has turned out, and I am finished with it. When I am done, I again select from the very top layer to the bottom and flatten my image. Once I'm completely done, I will save it as either a TIFF file or a JPEG file, depending on what format you want to use later for this image. This is how I process data from the Webb Space Telescope. This data has been nothing short of stunning, and I cannot wait to see the images that will be created from this telescope.